Okay, so hello everyone. In this video, I'm going to explain the new subtopic, which is gradients, tangents, and normals. Actually, you can find the subtopic on your book. So please just open your book, the Pure Mathematics one. I don't know what page is that, but if you going through the book, you will find this subtopic, which is gradient, tangent, and normals. Okay, so in this video, I'm going to introduce you with the new term, which is here normal. What is normal? Okay, but before that, I need to remind you again what is the meaning of the tangent. Okay, so actually I already explained this before. What is tangent, miss? Tangent is actually the curve. Okay, there is a curve and then there is a line that touch the curve. That's why here the tangent. Okay, so that line is only touching the curve. Remember, only touching, it's not cutting the curve. Okay, that line what we call as tangent. However, we have a new term which is normal. What is normal, miss? This normal line is having the relationship with the tangent. What is the relation between them? So actually, if there is tangent, here is the tangent, and there is another line, that line is actually perpendicular to this line. Okay, remember, perpendicular, having the degree 90 degrees. Okay, let's just make it like this. This line, the purple line right here, this is what we call as normal. This is normal, while this is tangent. Okay, so what we are going to discuss in this video, actually, how do we find the equation of both lines? Because they are both lines, that's why both lines have equation. Okay, have names, have function. That's what we are going to know in this video. Okay, so how do we find the tangent and normal equation? I will start from the tangent equation first. If you still remember the linear equation, okay, how do we find the linear equation? How do we create the linear equation if we know one point only? Okay, remember this formula. Y equal y1 equal mx minus x1. Okay, we will use it, right? Okay, so if I have specific point here, point A, which is this point A is x point y, this is x1 and this is y1. Let's take example, this x1 is 2, this y1 is 3, like that. Okay, so how do we find the linear equation using this specific point given? We just need to, how? Yes, we just need to substitute the value of x1 and y1. Right here, sorry, it is 3. And then this m, we're going to find the gradient of the line. And then here, x minus 2. Now, the next problem. How do we find the gradient? Okay, so how do we find the gradient of the curve? Remember, if we want to find the gradient of the curve, we need to find the first derivative. Okay, so meaning m is actually equal with dy dx, with f(x) and x, with y(x) and yeah, you name it. All of these are the same. First derivative. All of the symbol right here is actually the first derivative. So don't be confused. Okay, so that's why the m, we just need to find the derivative, the first derivative function, the first derivative of the original function. So if we have fx, which is this fx is a curve, okay, this fx is curve, we just need to find the first derivative of this fx. So for the m right here, we just need to find the f(x) and x minus 2. And then, not yet finished, so that we know the exact value of the m or the exact value of the gradient, actually we need to substitute the value of x. With what value? Means with two value that already known, that already given before. Okay, got it? Okay, so we just need to make here f(x) and 2, x minus 2. Done. Okay? Now, let me just give you the example. Let's take an example. For example, the f(x), x to the power of 2 minus x. Let's say like this. This is the curve, okay? Now, we are going to find the equation of the tangent line of this curve. Then, let's just continue our work. Find the f(x) and x first. How do we find the f(x) and x? Remember derivative. 2 times the coefficient here 1, right? 2 times 1, which is 2. X will be still x, and then to the power of 2 here, 2 minus 1. We need to subtract it with 1. I think that's clear already, yeah? Here, the x actually have the 1 power right there. So 1 multiplied by minus, it's gonna be minus 1. However, the x will be 1 minus 1, and then here x minus 2. Like that. Okay, we will continue again. Here 2, x 2 minus 1 to the power of 1 only. And then here 1x, x to the power of 1 minus 1. 1 minus 1 is 0. So x to the power of 0 is 1. So only 1 left. Okay? Here x minus 2. The next. I told you before that we need to substitute the 2, the x, in the first derivative with the value of 2. So after we derivate the function, now we substitute the function, the x, with the 2, with the value of the x. Okay? Where does it come? The 2 means, again, from here, from the specific point. That is from x coordinate. Okay? So we will have y minus 3, 2 times 2 minus 1, x minus 2. Here y minus 3 equal 4 minus 1, x minus 2. So we will have y minus 3, this is 3. I do it one by one so that you understand. Next, y minus 3 here, expand the brackets, 3x minus 6. And then next, here the minus 3, we will move it there, it becomes minus minus 6 plus 3. Here y, 3x plus minus 3. Okay, then done. This is already the what do we call it? The equation of the tangent. Okay, you got it already? Okay, so that is the way, one of the method how to find the equation of tangent. Now, the next problem is here, the normals. How do we find the normals equation, miss? Okay, then what makes them different actually is only the gradient. Remember that. What makes the normals and also the tangent different is actually in the gradient. Why like that, miss? I have told you before, if we have m1, the gradient 1, the line 1, okay, if we have line 1 and then we have another line here, line 2, that the relation between them is perpendicular to each other, Then the gradient of the first and the second one, what's the relation? Okay, yes. So m1 is actually will be equal with minus 1 over m2, or just vice versa. This is m2 is actually 1 over minus 1 over m1, like this. Okay, then how do we find the gradient of the normal line? Then, because we know it already, the gradient is 3, m1 is 3, right? The gradient of the tangent, this is for the tangent. Now, we have it already 3, so m2, we will get it minus 1 over 3. Then done. After that, what else? Then, you just need to change the value there. Y equal m2 x minus 3. Because we have found already the tangent, right? That's why here minus 1 over 3x minus 3. Then done. This is already the equation of normal line. Okay, understand? That's why if you pay attention at this formula, we will have the tangent equation. Right here we have y minus fa equal f accent a x minus a. However, in the normal, we will still have the same, but the difference is on, yes, correct, on the gradient. The gradient will be minus 1 over f accent a x minus a with the specific point a point f a, like this. This is x, this is y. Okay, so this is the very important thing to understand. What makes them different is only at the gradient itself. Okay. Okay, so after my explanation, I want you to do the number 3, number 4, number 5, and also number 6 at the page 165. And at the end on this mathematics class, please submit it to the teacher. Yeah, your practice, it will be submitted. I want to check you do it or not. Okay, so please do it well. Okay, thank you all. God bless you.